In early 2026, developers monitoring the Open Router usage leaderboards noticed a statistical anomaly. A completely unannounced stealth model had appeared on the platform, and its request volume was surging past established enterprise systems. Operating under the codename Hunter Alpha, the model rapidly climbed the usage charts. There was no marketing or white paper attached to the API endpoint. This scatterplot charts coding and agentic benchmark performance on the vertical axis against the API cost per 1 million tokens on the horizontal axis. An API, or Application Programming Interface, is the set of rules that allows developers to connect their apps to these models. When we plot standards like OpenAI's GPT 5.2 Codex and Anthropic's Claude Opus 4.6, they score highly on performance, but carry a high compute cost. Hunter Alpha matched their performance while shifting significantly to the left on the cost axis. The horizontal gap reveals a significant cost discrepancy. Hunter Alpha was executing complex logic tasks at the same level as the top US models, but required a fraction of the expenditure to do so. On March 19, 2026, the identity behind the codename was revealed. It was the MIMO V2 Pro, developed by Xiaomi. Xiaomi's transition from a consumer electronics manufacturer to a developer of top-tier foundational software shows that the technical capacity to build world-class AI is no longer the exclusive domain of specialized software research labs. The baseline specifications for MIMO V2 Pro include a 1 trillion total parameter count and a 1 million token context window. A context window is the maximum amount of data the model can process and remember in a single interaction. These specifications are calibrated for autonomous agent workflows. We are moving past single-turn chatbot interactions towards systems that independently process continuous data, execute multi-step task planning, and correct their own errors over autonomous repeating loops. But continuous looping introduces a hardware threshold. If an AI agent takes too long to reason through a single step, the cumulative delay across hundreds of autonomous steps results in latency that makes the system unusable. MIMO V2 Pro avoids this by decoupling its total parameter size from its active inference compute. It maintains high-level autonomous capability by calculating only a small fraction of its total network for any given task. Running a standard 1 trillion parameter model requires massive amounts of VRAM. VRAM, or Video Random Access Memory, is the high-speed memory on a graphics card that stores the model's data during active calculations. Traditional architectures rely on a process called dense activation. This means every single parameter in the neural network must be loaded and calculated to generate every single unit of output. When a dense model is forced into the continuous loops required by autonomous agents, it creates a massive memory bandwidth drain. The system must move 1 trillion data points through the processor for every step of the task. This graph plots compute cost over time. Under dense activation, an autonomous agent creates an exponentially rising curve, causing operational costs to spike. We contrast this with the flat cost of a single chatbot prompt, which ends after one output, keeping demands low. This creates an economic roadblock. 1 trillion parameters are necessary to store world knowledge for reasoning, but activating them all simultaneously across continuous loops drains budgets. Deploying a traditional dense 1 trillion parameter model for autonomous tasks is mathematically and economically unviable for widespread use. Xiaomi's solution is a mixture of experts, or MOE, topology. An MOE is an architecture where a large neural network is divided into smaller, specialized subnetworks, or experts, that handle specific types of tasks. Instead of a monolith, MIMO V2 Pro's 1 trillion parameter pool is segmented into specialized expert clusters. A task prompt hits a central router network that evaluates the required logic. The router selectively activates 42 billion relevant parameters, leaving the remaining 958 billion completely dormant. This allows the system to tap into the knowledge of a 1 trillion parameter pool while executing the calculation at the speed of a much smaller 42 billion parameter network. By ensuring only a fraction of the network is active at any given millisecond, sparse activation solves the memory bottleneck and lowers the cost of continuous reasoning. Active parameters are only one part of the problem. Autonomous agents also require large context windows to process entire codebases or datasets before they can begin planning. MIMO V2 Pro targets a context window of 1 million tokens. The roadblock for most models at this scale is the quadratic scaling of standard attention mechanisms. The attention mechanism is the math the model uses to determine how every word in a sentence relates to every other word. In a standard attention calculation, the model checks every token against every other token. In a small prompt, this matrix is manageable, but as the count approaches 1 million, quadratic scaling causes intersections to explode. The massive computational load causes a complete memory failure. This exponential memory curve cannot be solved by simply adding more hardware. The calculation itself becomes the bottleneck. Without a structural change to how these relationships are calculated, autonomous workflows that require long-term memory remain impossible. MIMO V2 Pro implements a structural change, the 7-to-1 hybrid attention mechanism. Rather than brute forcing a global grid, the architecture compresses the attention calculation. The 7-to-1 ratio optimizes the requirement down by a factor of 7, mapping relevant connections without querying the entire dataset. A sliding window mechanism extracts necessary data without expanding the computational grid. This ratio bypasses quadratic scaling, allowing the model to hold 1 million tokens in memory while maintaining high inference efficiency. Using these efficiencies, MIMO V2 Pro ranks 8th globally and 2nd in China on the Artificial Analysis Intelligence Index. Architecture dictates market economics. Because sparse activation and hybrid attention reduce server load, Xiaomi offers lower API rates. Input costs are $1 per 1 million tokens, and output costs are $3 per 1 million tokens. These rates apply to active contexts up to 256,000 tokens. Measured against the rates of high-end US models like GPT 5.2 codecs, the financial difference is significant. MIMO V2 Pro delivers similar reasoning capability at roughly 1/6 to 1/7 the cost of its primary rivals. This cost collapse transitions autonomous agentic workflows from research projects into economically viable products for developers. Xiaomi is focusing on native software ecosystems rather than just developer API endpoints. The model is embedded into the Xiaomi browser, the MIMO Studio, and Kingsoft WPS Office. Placing an autonomous 1 trillion parameter agent natively into consumer office software is only possible because of the sparse inference constraints designed into its architecture. The success of autonomous AI models will not be determined by gross parameter counts, but by the mastery of active inference efficiency.